Chemistry is involved in every aspect of our life, including in the food that we eat. Food is all about chemistry, where the ingredients are chemicals. Cooking is a set of chemical reactions, and even the spoon that we use is a chemical. There are two ways chemistry is involved in cooking. Firstly, fire is combustion, which is a chemical reaction. It cooks food, heats homes, and runs vehicles. When we cook, foods change. Some of those changes are physical and some are chemical. Some physical changes are those that involve phase change, like boiling water or reducing a sauce. Those are reversible. If we captured and condensed the steam and added it back to the pot, we have reversed the change. We have not formed anything new. If we heat something and the heat content was the only change, then that is reversible and therefore a physical change. Chemical changes form new substances from reactants. They are not reversible. For example, once you have cooked an egg, the proteins have uncurled or denatured and tangled with water, turning white. The yolk has solidified. These can't be turned back into a raw egg. Chemistry is essential to the history of how we produce, store, and consume food, from preservation, pesticides, and quality testing to artificial additives and substitutes. Chemical food additives have a very long history. In ancient China, paraffin wax was burned to ripen fruit, and this worked because it causes traces of ethylene and propylene to combine with the food. The Egyptians colored food with saffron, while the Romans added alum, which is potassium aluminium sulfate, to bread to make it whiter. The first deliberate use of a food additive was likely salt to preserve foods such as fish and meat, which works by dehydrating the food to limit bacterial growth. However, it wasn't until the 19th century that the microbial cause of food spoilage was understood. The use of food additives increased dramatically during the Industrial Revolution, with toxic compounds used liberally in factory food production. These range from the coloring of Gloucester cheese with red lead to sweets being colored green with copper arsenide, also used in the wallpaper that may have been a factor in Napoleon's death. Let's take a well-known example of instant noodles. Instant noodles are well known for being delicious, cheap, and easy to prepare. They can last for up to 12 months on the shelf, which makes it a very well-known and accessible option for a lot of people, where the shelf life of instant noodles can range from 4 to 12 months, depending on environmental factors. So finding ingredients that are stable for this long, especially fats and oils that are prone to oxidation, is a culinary challenge and is a very rare find, which is why a lot of people do turn to instant noodles for its efficiency. Antioxidants, like tertiary butyl hydroquinone, can extend the shelf life of instant noodles by preventing the oxidation of fats and oils. This happens by donating electrons to neutralize free radical, which stabilizes this radical's instability. That is the chemistry behind instant noodles.